Good evening everyone. Today we are going to see how to perform measurement system analysis using Minitab, and the method that we are going to use is Gage R&R study. So the background for this particular video is, so whenever you are going to work in a development area, so you will be conducting multiple experiments. So whenever you are going to conduct multiple experiments, so you will be taking the samples for the analysis, and in that particular case, if there is any unexpected or any abnormal results which are being reported, so it is going to have a huge impact on the development. Why? Because if there is much variation in the analytical results observed when compared to the required or when compared to the ideal values, so automatically it is going to have a huge impact on your development. So whenever you are going to perform a developmental study, we need to ensure a proper analytical method, and also we need to ensure the system that you are going to use for the analysis is in right condition, and also the limit or the tolerance is going to be within the acceptable range. Okay, so in order to estimate the precision, or in order to estimate the variations that are being given by this analytical instrument, so we are going to perform this measurement system analysis, and for that we will be using Minitab. So before going into the topic, we should understand about the difference between accuracy and precision. Usually we'll be using both the words like accuracy and precision interchangeably, thinking both are the same, but there is a gap. So here, if you are able to see, there are total 4 boards, and let's say this is the first board. In this particular first board, all the data points are centered. So the black dots are represented by, or the data points are being represented by the black dots. So here in this case, if you are able to see, all the black dots were placed at the center of the board. That means, so there is no difference between the ideal value as well as the data points. So from this we can say the data points are accurate. And also coming to precision, so precision means it's all about the consistency. So here consistently all the data points are located at the center part. So from this we can say, so the system is highly accurate as well as highly precise. And coming to the second board, here if you are able to see, most of the data points are lying at the center, but they are not consistent. So from this we can say, so the system is accurate, but it is having low precision. So coming to the third board, here in this particular case, so the data points are falling away from the center, but they are consistent. So from this we can say it is of low accuracy and high precision. So coming to this last board, here in this particular case, all the data points were scattered away. So from this we can say, so it's of low accuracy as well as low precision. So this is the difference between accuracy and precision. And now let's go with the initial topic, that is understanding the variation. So most of the cases, the variations are due to 2 things. So I'll use the smarter to represent the factors of variations. The first one is, so let's say this is total variation, and in this total variation it is being completely attributed by 2 factors. One is the material. If you got any abnormality during the material manufacturing, so what will happen is automatically the system is going to show you some wrong results or some abnormal results. So the total variation can be attributed due to the material, or in other words we can mention this as parts. And coming to the second one, so the second one is going to be due to the measurement system variation. So if the analysis, or if the analytical instrument is having some abnormality, so automatically it is going to give us certain variations. So there is nothing but the measurement system variation, or else we can mention it as gauge, in other words. Why? Because you are going to measure using the gauge only. And now coming back to this materials or parts. So if there is any variation available in this material or part, so then we need to investigate in the manufacturing process. So whenever you are going to have certain variations in this measurement system, then we have to again reclassify, or again we have to go in depth. So the first thing is accuracy, like whether the system is accurate or not. And the next one is precision. So whether the method is precise or not. So again coming into this accuracy, so we can give the breakup as bias, linearity and stability. So I am going to mention it as bias, linearity and stability. And coming into this precision, so I can break this into repeatability. Why? Because it's all about consistency, repeatability and reproducibility. So this is how we can classify the total variation into. So I'll do one thing. So this is how we are going to classify the total variation. So we can classify the total variation into two parts. That is either the material or parts, and the second one is due to the measurement system variation or the gauge. And coming to the variations which are due to the measurement system, so it can be classified into two categories: accuracy as well as precision. So accuracy can be again classified into three things: one is bias, the second one is linearity, and the third one is stability. And coming to precision, so we can say total two things: one is the repeatability and the second one is the reproducibility. So we are going to check about this. Why? Because it's all about like the abnormality in the measurement system usually dependent upon the consistency. So we are going to see the repeatability as well as reproducibility. So before going into that, we should understand what is exactly the repeatability means and what is exactly the reproducibility means. So repeatability means it is going to be the variation in measurements obtained, so with one measurement instrument when used several times by same persons while measuring the identical characteristic of a same part. Okay. And coming to reproducibility, so it is a variation in the average of the measurements made by different persons using the same measurement instrument while measuring the same characteristics on same part. So we can also call this reproducibility as appraiser variation. So this is about the variations, and now let's take some case study and let's try to understand using Minitab. So to understand that, I have taken certain data I have collected. So here I have collected total 5 parts or 5 samples I have collected, and each sample has been analyzed twice by total 3 operators. The operator or the analyst names is, let's say, A, B, C. So total I have collected 5 samples, and 5 samples has been analyzed by 3 operators twice. So the total number of analysis or runs are going to be 3 operators into 5 samples into twice. So there will be total 30 measurements. So here I got the measurements. Okay. So first of all, just try to copy this into, or just try to get all this data into 3 columns. One is the parts, the second one is the operators, and the third one is the measurements. So just copy these things and open the Minitab. And just place the data points or the data that we have gathered into this Minitab worksheet. So I have just pasted it, and now for performing this Gage R&R study, just get into stat and get into this quality tools, and in this you'll be finding Gage study. So here if you are able to see, there will be three main things. One is Gage R&R study crossed, nested and expanded. So we should understand what type of study we need to perform. So the first one is crossed. So let's see when we are going to use this. So when each part or each sample is being measured by multiple times by each operator. So in such a case, we have to go with crossed. That means, so each sample is going to be measured multiple times by each operator. So it's nothing but a replications of the same measurement. So in that case, we should go with a crossed. And coming to nested. So nested means, so this is something like a destructive testing or crash testing. So the samples which you are going to analyze once cannot be tested the second time. Why? Because already the sample should have expired or the sample should have crashed. Okay, so this is something like when each part is measured by one operator only. So in the crossed, so each part is being measured multiple times by each operator. But in the case of nested, so the measurement is going to be taken only once. Why? Because this is something like a destructive testing. And coming to expanded, so this is something like when we need to include more factors than operators and parts, so then we should get into this expanded. So in the given case, we got total 3 operators and we are going to measure 5 samples and we have measured it twice. So I'll be selecting crossed. So just click on this and in this just select the columns. In this part numbers, so just mention this, double click, and coming to this operators, so just double click on this, and coming to measurement data, just double click on this. Here you found total 2 method of analysis. One is ANOVA and the second one is X bar R. So out of these two things, ANOVA is going to be more accurate. So I'll be selecting ANOVA and coming to here. So these things we need to select. If you want to provide any of the details, you can mention that. And in these options, so we have to mention the steady variation is 6. Why? Because I want to have 6 times of the standard deviation. And coming to this tolerance, so I'll be selecting it as 5, like the difference between upper spec and lower spec. I have selected 5 and I would like to perform this with 95% confidence level. So I'll be clicking it OK. And now just click on this OK. Now you got this data. So this is the output window. Just drag this worksheet below and in this you can find now. So Minitab has performed two-way ANOVA with interaction and without interaction. So the difference between with interaction and without interaction is, so the values or the sources for which the p-value is far greater than 0.05 will be neglected in this without interaction. So here in this case, if you are able to see, the p-value is 0.928 for the sample parts versus the analyst or operator. So it is far greater than 0.05. So what Minitab is going to do is, Minitab is going to omit these results in this without interaction. So coming to here, so here again we got the sample parts, analyst or operators, and the repeatability. And the p-value is almost 0 for the sample parts. That means since it is less than 0.05, so we can say that this is going to be a significant factor. That means the part-to-part variation is going to be high. And the total variation is going to be attributed by the sample parts majority or majorly. And coming to this analyst or operator, so the value is 0.268. It is greater than 0.05, which means so their contribution is going to be very less. And now let's check the contribution part. So here you got a contribution percentages. So here in this case, if you are able to see, we got 2.94% for this total Gage R&R, and part to part we got 97.06. So from this we can say the measurement system analysis or measurement system is having less variation, like the variations attributed by the measurement system is going to be low and the part to part is going to be high. So for this to understand better, so the standard is like for percentage contribution, if it is less than 1%, so the measurement system is acceptable. and if it is between 1% and 9%, so measurement system is acceptable. But depending on the application, the cost of analysis and other factors, if it is greater than 9%, like the contribution, in this case system is not acceptable. So this is about the percentage contribution. And in a similar way, so for the percentage study variation, so if the percentage study variation is less than 10%, so measurement system is acceptable. And if it is between 10% to 30%, so system is acceptable. And it depends on the application, cost and other factors. That means there is still a margin for improvement. And if it is greater than 30%, so the measurement system is not acceptable. So again, we need to perform certain calibrations or fine tuning so that the error in this percentage study variation should be reduced to below 30%, or it can be further improved to below 10%. Okay, now getting into Minitab. So just now we have seen about the percentage contribution. So the percentage contribution should be ideally less than 1%, but here in this case it is almost 2.94. So it's marginally near to the desired value of 1%. So it is between 1 to 9% ideally. So from this we can say that the gauge is accepted, or the measurement system is accepted, but further it requires some fine tuning and there is a room for improvement. And the major variations are being attributed by this part to part. That means whatever the samples that you have collected, so there is a variation in these samples. So what we have to do is we have to focus on the process so that the variations in the metal or the uniformity in the metal can be improved. And coming to this gauge evaluation, so here in this we need to identify this percentage study variance. And this percentage study variations, so we have to check about this part to part and the total gauge R&R. So in this part to part, it's almost 98.52%. As it is almost 98.52%, we can say the majority of the variance is attributed by this part to part. That means there is a problem with the material when compared to the gauge. So the issue or the percentage variance in this gauge is only 17.15%. So as per our notations or as per our interpretation, if the study variance is between 10% to 30%, so the system is acceptable, and it depends on the application that you are going to use for, and also the cost of analysis, and also there will be certain other factors. Since it is almost 17.15%, we can say it is marginally acceptable, but there is a more room for improvement. So this is how we are going to interpret this gauge evaluation. And the next one is the number of distinct categories. So from this number of distinct categories, again we can say whether the system is acceptable or not. Basically, whenever this number of distinct categories is less than 2, that means the measurement system is of no value for controlling the process. So if the number of distinct categories is equals to 2, so we can classify the data into high and low. If the same number of distinct categories is equals to 3, so again we can classify it into low, middle and high. So ideally the number of distinct categories should be equals to 5 or greater than 5 for having an adequate measurement system. Okay, and now coming to this graphical interpretations. So the first one is the components of variations. So in this, if you are able to see, the values of this part to part is going to be high. So from this we can say the variance or the variation is highly attributed by the part to part variations. And coming to this analyst or operator evaluation. So in this graph, if you are able to see, all the data points are lying within the control limits, but the variation is being shown very high in the case of operator B. See, it has started here and it has ended here almost. That means the variations are high. And coming to this analyst or operator, like the X bar R chart. So from this we can see, so most of the data points are falling away or outside the control limits. So that means the sample parts variation is going to be very high and we need to reduce it. So coming to this measurements by sample parts. So here if you are able to see, the sample parts are going to be consistent here. So it is, though it is slightly increasing, like here on the x-axis we got the samples. So as I have collected total 5 samples, so if you are able to see, the values are going to be increased further. That means the variations in the samples are going to be high. Even though I have taken the samples from a single batch, so here I got more variations. Maybe it depends upon from where I have collected the samples. And coming to this next graph, that is the box plot. So it is like the measurements by the operator. So here if you are able to see clearly, there is no much variance between this A and B operator, and there is a slight variation by the measurements that are being taken by this operator C. And finally, the interaction of sample parts and the operator. So this is what we have seen, like so this is the interaction that has been missed. Like the p-value what we have seen here, it is 0.928 for the interaction between sample parts and the analyst. So this graph represents that particular case where the p-value is almost 0.928. So that means this particular interaction is not having any impact. So just neglect this. So this is how we are going to interpret the Gage R&R and how you are going to classify or you are going to analyze the available measurement system and its applicability for analysis. So if you like our video, please share and subscribe. Also, if you have any questions in this particular case, so just write a mail at like pharmacalci823@gmail.com, and I'll be attaching this particular Excel sheet and also the Minitab file, and I'll be providing you with a download link. Please check the download link in this description. Thanks for watching the video.